Good morning, everybody. Welcome to the last day of the week. It's Friday, and hopefully the weather will be good for the weekend. We're going to start this morning's maths with our usual starter, 5 questions to answer in 5 minutes, or as close to 5 minutes as you can. Mixture of mental strategy and written questions as always. And press pause when you're working and press play when you're ready to listen to me talk. Okay then, off you go. Okay, first question. I've picked 70 plus 20 up here, a nice mental strategy question this morning. This is a straightforward place value question. The only digit that's going to change is the tens column. So all you need to do is count on your tens. So 70 plus 10 and 20 leaves you with 90. So 70 plus 20 is 90. You should all have that. Second question, 4/5 of 50. Now, remember, we've talked about this before, that when you're finding a fraction of a number, you should take the number, the whole number, which in this case is 50, you divide it by the denominator. Okay, now in this case, that will get you 1/5. Okay, so 50 divided by 5 is 10. So 10 would be 1/5 of 50, but the question's asking you to find 4/5. But if you already know what 1/5 is, then all you need to do is multiply that number, the number you've got left there, 10, by the numerator, which in this case was 4. So you know what 1/5 is, you times it by 4 to find 4/5. So 10 times 4 is 40. Next question we're going to look at is a written question, and it's 38 times 5. So I've given you 2 methods as always. First method, we stick with the most efficient method, which is short multiplication, standard method. First thing we're going to do is make sure we've lined those columns up properly, and then we can begin. So we start with the ones column. 8 5s are 40. We must make sure we carry that 4 across into the tens unit. And 3 times 5 is 15, plus 4 is 19. So the answer to 38 times 5 will be 190. Secondly, again, always partitioning. If we partition 38 into 30 and 8, and then we have to multiply each part by 5. So 30 times 5 would be 150, and 8 times 5 would be 40. And if you recombine those numbers, you'll get 190. Okay, our next calculation there is 49 plus 33. Now, I've given you 2 methods here. The first one I'm going to start with is partitioning. And the reason I've not gone to column addition is because this should be a mental strategy question. So what I've done is broken up 49 and 33. I've partitioned the numbers, and I'm going to add the tens together first. So 40 plus 30 would be 70, and then I'm going to add the ones together. 9 plus 3 would be 12, and if I recombine those numbers, 70 plus 12 will give me 82. Second method, I could add 1 to 49 to make 50 if I wanted to, and then add the remaining 32 onto 50, which again will give me 82. Doesn't really matter which method you use. Personally, I like method 1, but that's because I like to partition, but it's entirely up to you. Okay, the second written question this morning, the last question of our mental warm-up, is straightforward subtraction question. Now, what I would be saying here, the most efficient method would be column subtraction, and we'd use decomposition or exchanging. So if we start off with the ones column, 3 take away 8 you cannot do, so you would need to exchange one of the tens, okay, and bring it over here, and then that gives you 13. Then this number then becomes 13. 13 take away 8 then would be 5, and then we can move on to the next column. 7 take away 4 would be 3. We move to the hundreds column. 4 take away 9 we can't do, so again we would need to exchange from the next column. That makes this number 14. 14 take away 9 would be 5, and then leaves us with 7 take away 2, which is also 5. So the answer to the question would be 5,535. Okay, our learning intention this morning for the main part of the lesson is to be able to identify symmetrical figures. So we're taking the learning that we've gone from or been going through this week about classifying shapes. We're just going to park that for a moment and we're going to start to look at symmetry this morning. So our star words this morning would be symmetry, 2D shapes, squares, rectangles, and then lines of symmetry. Okay, all of those words will be quite important during the course of this morning's lesson. So our in focus task this morning, the young lady on the left there is saying, is it possible to fold a square or a rectangle in half so that one half falls exactly on the other half? So what they're saying is it possible to fold these shapes in half so that when you fold it over, one half will land exactly on the other half. There'll be no bit sticking out. It will be perfect. And that's our sort of the main crux of our learning this morning. We'll come back to this during the course of the lesson. Okay, let's learn. So we're going to start with a square this morning. Now, if we're thinking about folding shapes here, now the young lady here has put a folding line in on her square here. Now you remember the question asked us, could we fold that square in half exactly along a folding line so that it lands exactly on the other half, that there are no bits sticking out? And you can see here that with this shape, if we fold it along this line here, the folding line is halfway down the shape on both sides, and if we fold it over, we'd be left with this shape here. So we can do it folding upwards on the square. But the big question is, can we fold it any other way to get the same result? Because the question never said, can we fold up? It just said, can we fold it in half? So if we look at this second slide here, this young man has gone at it from a different way. Now he's gone from corner to corner. He's folded along the diagonal line here. But again, when he folded it over, so you can see he's folded over, the arrows are showing us where he's folded. This is the shape that he's left with. And yes, again, he's been able to fold it exactly over. There are no bits sticking out. It's landed exactly on the other shape, the other side of the shape. Then the final one, the young lady had a look at this one here. So she'd already folded up, but this time she's folding across. But again, her dotted line is halfway along the shape. She's going to fold it over, and again, she's going to have no bit sticking out. It's going to land exactly on this part here. Now, the speech bubble, which she's speaking at the bottom here, the folding line, she says, is a line of symmetry. And we talked about that as one of our star words this morning, and she's quite right. Now, in this question so far, we've been talking about folding lines. Well, these folding lines are lines of symmetry. And you can see that on a line of symmetry, what's on one side of the line of symmetry, or the folding line, has to be exactly the same as what's on the other side. If it isn't exactly the same, then it's not a true line of symmetry, and it is not symmetrical. So one side has to look exactly the same as the other. How about the rectangles? This young lady did this. And then she said, is this a line of symmetry? What I want you to do now is to think back to the square that we looked at just now. Think back to the rule that we've just come up with for lines of symmetry. And remember, everything that's on one side of the line has to look exactly the same as what's on the other. That if we were to fold it along that line, it would cover exactly. So with that in mind, I want you to press pause and just think, is this a line of symmetry? Okay, well, hopefully you've all been able to think, yeah, actually, Mr. Nugent, this is a line of symmetry. Everything that's on this side is exactly the same as what's on this side. There is no difference. If I was to fold this in half, it would look exactly the same. So yes, on this rectangle, this is a line of symmetry. She then went on, the same girl, then went on and did this. And what I want you to do now is to think really carefully. and tell me, based on what you've learnt so far in this lesson, is this a line of symmetry? Is this dotted line here a line of symmetry? Press pause now while you're thinking and press play when you're ready to resume. Okay, well then. Remember the rule we said for lines of symmetry, the folding line. Everything that's on one side of the line has to look exactly the same as what's on the other. So in this case, you can see quite clearly that there is more of the rectangle on this side of the line than there is on this side. And that means that this cannot be a line of symmetry. So the answer to this is no. Now this one's a little bit trickier, because on the square just now, when we went from corner to corner, remember it was a line of symmetry because what was on one side was exactly the same as what's on the other. If we folded it over, it would look exactly the same. But I want you to think now about the rectangle. Is this a line of symmetry? Press pause now while you're thinking about it and press play when you're ready to resume. Okay then, well, the answer to this one is that no, this isn't a true line of symmetry. Okay, and the main reason, because it does, and I get why it could be quite confusing, because it does look like it should be. I mean, after all, if the square corner to corner was a line of symmetry, then surely this should be. But remember our rule from earlier on, we said that if we folded along that dotted line, if we folded it over, would it land exactly on the shape on the other side of the dotted line? And the answer to this is no, because if we were to fold this over, the corner for this one would be up here somewhere. Okay, if you're not sure about that, cut yourself out a rectangle on a piece of paper and just fold it from corner to corner and just see what happens when you fold it over. Okay. Okay, now it's your turn. Now we've got some pictures on the screen here, ranging from a butterfly all the way along to a house here. And what I want you to do is to tell me, which of these shapes do you think, or pictures, do you think have a line of symmetry? Which of these do you think has a line of symmetry? Okay. Press pause while you're just having a look at it and deciding, and press play when you're ready to hear me talk about it. Press pause now. Okay, well, if we look at this then, we've got the butterfly here, we're saying yes. Now, if I just quickly draw the lines of symmetry in, if I was to draw the line up through there, you can see that what's on this side of the dotted line would mirror exactly what's on the other side. So I would say yes, this one is a line of symmetry. On the leaf, I have to be careful here to get it in the exact place. Again, you can see that there is one line of symmetry here going up. So what's on this side is exactly the same as what's on the other. Now, the umbrella is not symmetrical. If I was to draw a line down through the middle here, you can see that it looks different on this side of the line to on this side. So that cannot be a line of symmetry. And if I draw the line across or diagonal, it still wouldn't be have a symmetrical line to it. The bird, again, not really. It doesn't matter which way round I look at it. The bird is not symmetrical in any way, shape or form here. So that one would be a definite no. Now the house, is it symmetrical? Now I've put down there yes. Have I made a mistake? Press pause now and look at the mistake. Has Mr. Nugent made a mistake? Surely, if Mr. Nugent was to draw a line of symmetry down there, surely the house is symmetrical, look, because what I'm looking at on this side looks the same as on this side. Surely the answer is yes. Just press pause now and think, might Mr. Nugent have made a mistake? Press play when you're ready to carry on. Well. Yes, Mr. Nugent has made a mistake. And why is he made a mistake here? Because surely this house looks pretty similar on both sides of the line here. The sloping roof, the two windows, the half a door, everything looks the same. But there is one difference. Up on the roof here, there is a chimney. And there is no chimney on this side. So you must look really carefully when you are looking for lines of symmetry, because just a small detail like that can make a difference between a shape being symmetrical or not. Okay, the second part of the guided practice this morning, there are 4 shapes on the screen in front of you. What I want you to have a look at doing, could you find one line of symmetry for each of these shapes? Press pause now while you're working and press play when you're ready to hear me talk about it. Okay, so if we wanted to look at this now, my first shape here, the triangle, to begin with, doesn't look like it should have a line of symmetry. If I cut down there or I cut across there, it doesn't look right. But I could cut across diagonally here. And if it's not as accurate as I'd like it, but if I cut across diagonally, you can see that what's on this side of the line would fold across and would be the same as on the other. So this is the line of symmetry for this shape. This one up here is a horizontal line of symmetry, but you can see that if I folded that across, it would fold exactly onto the shape there. The arrow down here now only has one line of symmetry. It comes down there. If I was to fold this across over the dotted line, it would land exactly on this side. Now the trickiest one is this one here. The trickiest one, I think, is this one here. If I was to draw the line down there, it wouldn't be right. If I was to draw the line across there, it wouldn't be right. What I need to be thinking about here is this diagonal there. And if I was to fold that across, then it would have, this would be its line of symmetry. It would land exactly on the shape over here. If I went this diagonal, would it do it as well? Yes, it would. So this shape actually has 2 lines of symmetry. So if you've done 2, absolutely fabulous. If you've got one of those, brilliant. Good job. Okay, our independent learning for this morning. I'd like you to have a look at worksheet 5 on page 133 of your workbook. Okay, press pause while you're working and press play when you're ready to see the plenary. Okay, I hope that was okay for you. The last part of the lesson today, I've gone slightly out of sequence from the textbook, but I think this one's quite a nice activity to finish on, just to pull your learning and your understanding together. Now you'll see underneath the video on the website, underneath today's video on the website, I've put a shape sheet. Okay, now you might want to print that shape sheet to complete this activity. On that shape sheet, you've got these 6 shapes, and what I want you to do is to try and find the lines of symmetry that there are for those shapes. Okay, and at the bottom here, what I want you to be able to do, because some of these shapes might not have a line of symmetry, some of them might. Okay, what I want you to do is to tell me whether or not they are symmetrical figures or non-symmetrical figures. Are there any shapes that would be symmetrical? Are there any shapes on there that would be non-symmetrical? So you're looking for the lines of symmetry, you're looking for the fold lines. So you might want to cut those shapes out and then have a go at folding. Hope you've enjoyed this week's learning, and I'll speak to you next week. Have a lovely weekend. Take care, year 4.